So in this video we're going to show how you can prove the derivative of the logarithmic function, and we're going to use implicit differentiation to do this. So watch. Let's say we've got a function y and it's equal to the natural log of x, just like that. Okay. Now we know that we can rewrite this in exponential form like this. We can say this is e to the y is equal to x. Okay, so this is our this guy right here is equal to this guy right here. Now what I'm going to do is I'm just going to differentiate both sides with respect to x. Okay, so this right here, well, we need the chain rule. Okay, so this is going to be dy dx times dy of e to the y. And this right here will just be 1, because d dx of x is 1. So now I need dy dx. Well, that's the guy that I'm actually looking for. Okay, that's the guy that we're trying to find. So let's solve that guy by itself. So this is dy dx times, now d dy of e to the y is just still e to the y. And so this becomes dy dx is equal to 1 over e to the y. But we know e to the y is x by this relationship right here. So that means dy dx is equal to 1 over x. So there it is. What we've now found is the derivative of the natural log of x, that's 1 over x. Just like that. So we now have this derivative for the logarithmic function. Now let's go ahead and look at what if we have a base other than e. So let's say, for example, we've got y is equal to, I don't know, log base, let's just call it a of x, and we want to find its derivative. Well, we're going to use the same trick here. So let's go a to the y is equal to x, and now we'll differentiate both sides. So d dx of a to the y is equal to d dx of x. So this right here is dy dx times d dy of a to the y, and this is equal to 1. dy dx is the guy we're trying to find. Now the derivative of the derivative with respect to y of a to the y, that's equal to the natural log of a times a to the y, just like that. So that gives us dy dx, the derivative of this guy is equal to 1 over the natural log of a times a to the y, and we know a to the y is equal to x. So this will be 1 over the natural log of a times x, just like that guy right there. Okay. So now the other thing that I should mention here is that these derivatives hold when x is greater than 0, and the reason for that. So on both these guys there are restrictions. We want x to be greater than 0. Well, why do we care about that? Well, look, if you take the natural log of x and you look at it as a function, it looks something like this. Well, it's only defined, this guy's only defined when x is positive over here. So clearly you can't differentiate when x is negative over here, because there is nothing. Okay, so we give that restriction. And the same holds true down here.